Now in the previous lecture, we have explained algorithm of insertion in single linked list. Now in this lecture, we are going to implement that algorithm in practice. So we have learned that we have three cases when we are inserting a node to a single linked list. So the first case is we are inserting a node at the beginning of single linked list. The second case is we are inserting a node at the end of single linked list. And the third case is we are inserting a node at any given location in the single linked list. So we will combine these three cases over here and implement a method in which we are going to insert a node at any given location. So let's get started. So I'm going to declare our method like this. So public void, so our method will not return anything, insert in linked list. Then our method will take two parameters. The first parameter will be integer, which will be the node value. So as you remember, while we are declaring our node over here in our previous lecture, we have said that the value of node will be integer. That's why here the parameter also will be the integer when we are creating an insert method for this linked list over here. So it depends on you. You can select whatever data type you want. But if you are selecting a string over here, you have to declare this node's value as a string over here as well in the node class. Now the second parameter will be the location parameter. So this parameter specifies that in which location we are going to insert a node to this single linked list. So if we set it 0, it's going to insert at the beginning of the linked list. So if the location is greater than the size of single linked list, in this case, it's going to insert at the end of single linked list. So if location is somewhere in the middle of single linked list, it's going to insert in that specified location. So these are two parameters that our method will accept. So the first thing that I'm going to do, I'm going to create a node which takes a node value over here. So this node will be created based on this node class that we created over here. So I'm going to initialize the instance of this node class as a node. So node and small node will be equal to new node. So here we are going to set the value of this newly created node value. So this is the value that comes from this parameter. Then after creating it, the first thing that we are going to check if this linked list is created or not. So if it is not created, we have to create it with this node. So if it is created, then we are going to check location parameter and insert a node in specified location. So the first condition will be like this. If head equals null, so in this case it means that our single linked list does not exist. So in this case I'm going to call this method create linked list with the value that we got from this parameter. So it's going to take value of this parameter, and then without doing anything we are going to return, because in this case we don't have any node in our single linked list. So by calling this method, this node value will be inserted to this single linked list over here. So single linked list with one node will be created in the memory. Now otherwise, if our single linked list is already created, then we are going to check location parameters. So I'm going to write else condition like this. Else if location equals 0, then in this case it means that we are going to insert this node value at the beginning of single linked list. So when we are inserting a node at the beginning of single linked list, the first thing that we are going to do, we are going to set the next reference of this newly created node to the first node, and head will be referenced to this node over here. Now we know that in the head we have now first node. So this means that if I put node.next equals head, it means that it's going to reference the first node. Then we need to change the head reference to point this node over here. So I'm going to do like this, head equals node. So with this node that we created over here reference to first node, and head reference to this node over here. This means that we have successfully inserted a node at the beginning of this single linked list. Now the next case is we are going to check that if the location parameter is greater than the size that we created over here, then in this case it means that we have to insert a node at the end of this single linked list. So because we have exceeded the size, so in this case, if we have exceeded the size, so we can only insert an element at the end of single linked list. So else if location is greater or equal to size of this single linked list, so the size comes from the property of this single linked list class. So in this case, we are going to insert it at the end of this single linked list. So we know that in case of single linked list, the last node reference to null. So this means that if this node that we created over here is the last node, then in this case the next reference of this node has to be null. So I'm going to set it to null. So after setting it to null, the next thing that we need to do, the last node has to reference to this node. So we know that in tail we have a last node now, so tail reference to last node. So in this case, if we access the tail.next, it means that we are accessing the last node's reference. So we are going to set last node's reference to this node because we are inserting this node at the end of single linked list. So now currently last node is tail, so tail has to reference to this node. Then we need to change the tail reference to point this node over here, because now after doing these operations over here, this node that we created over here is becoming the last node, so tail has to reference to last node. So with these 3 lines of code, we are adding this newly created node at the end of this single linked list. After doing so, the last case is we need to insert a node at any given location. So I'm going to write else condition like this. So in this case, as we explained before, we have to loop this through single linked list and find the specified location, then insert node at that location. So in this case, I'm going to start loop from the head. So that's why I'm going to create a temporary node here based on the node class, and this node will take the value of head. So we are creating temp node over here because we need to start loop through the head until we find the location that is specified in this parameter. So here we are going to start from the index of 0. So that's why I'm going to create a variable which will start from 0. Then while this index that we created over here is less than location -1, this means that we are looping till we reach the specified node. Then in this case, the temp node will be set to temp node.next because each time we are going to the next node, and index will be increased by 1. So every time we are going to the next node, an index increased by 1 until we find the specified location. So when this loop is finished, the temporary node over here currently reference to the node after which we should insert a new node. Now in this case, as we said, temporary node reference to the node after which we should insert a new node. So that's why I'm going to create next node over here, which will take the temporary node's next reference. So this is going to be a next node after the node that we are going to insert. So in this case, after taking the value of this next node, we are going to set temporary node's next reference to the node that we created over here. So node, then this node's next reference will point to this next node over here that we created over here. So this means that we are inserting this node between temporary node and the next reference of temporary node. So that's why node.next will reference to next node over here. So this means that we are updating newly added node's next reference to this next node over here. So basically what we did over here, we have reached to the location in which we want to insert a node. Then we have taken the next reference of this node and saved it in this next node. And then we have set the next reference of this currently node to the node that we created. And then the next reference of this newly created node will point to the next node that we created over here. So this means that we have inserted a new node between this temp node and this next node over here. So at the end, after finishing these 3 conditions over here, we have to increase the size of single linked list by 1. Because whenever we call this insert method, we can only insert a node to the single linked list. So that's why every time we are going to increase it by 1. So with this, we have finished creating our insertion method in single linked list. So let's see how this is working in practice. So what I'm going to do over here, I'm going to go to the main class. So inside main class, we have created an instance of this single linked list class, and then we have created a single linked list with the value of 5. Now I'm going to call insertion method in this main class and see that if this is working correct or not. So now in our single linked list, we have an element with the value of 5. So the first thing that I'm going to do, I'm going to insert a new node at the beginning of this single linked list that we created over here. So insert in single linked list with the value of, for example, 6, then as a location I'm going to put 0. So if I take this print statement from here and put it after this node, so first in the head value, which is the first node, we will have 5, then after insertion it should show 6. So let's run our code. So you see that after running, first it prints out the 5. So when we are creating a single linked list over here, we have only one element, so the first element is 5. So after insertion at the index of 0, this 6 is inserted at the first node, so that's why now head value is printing out 6. So instead of 0 over here, if I put, for example, 1, this will insert this node after the 5. So if I run our code, now you see that it will print out 2 times 5 over here because first node is not changed. So as you see, it prints out 5 and 5. So this means that the value of first node is not changed. So but instead of first node, if I print out, for example, here the next node's value, and if I run our code, you will see that one more time it's going to print out 5 and 6. So you see that our method works the way that we want. So let's try a different location in this case to see that if this is working correct or not. So in this case, if I put, for example, over here 3, which is the greater than the size of the single linked list that we created over here, then in this case, this element will be inserted at the end of this single linked list. So how can we see it? So we know that we have 3 elements in the linked list in this case. So if I put one more time next over here and print out the value, you'll see that this time it's going to print out the value of 7 over here. So then we'll put 7 over here and run our code. So you see that the third element in the single linked list is 7. So everything works the way that we want. Now let's see what's the time and space complexity for this method that we have created inside single linked list. So I have made it smaller to see all lines of this method in one screen. So here we can easily calculate time and space complexity of this method over here. So as always, we are going to start from the first line of the method. So in the first line, we have created an instance of node class. So we have created a new node with the value of node value. So this part of code will take one time complexity because here we are just creating a node and setting the value of node to node value that comes from the parameter. Then we are continuing to the next line of code. So in the next line of code, we have if condition in which we are checking that if head value is equal to null, then we are calling create single linked list with the node value. So we know that create single linked list method takes one time complexity. So this if condition over here will take one time complexity. Then we are continuing to the next if condition. So in the next if condition, we are checking if location is equal to 0. If it is, then we are setting node's next reference to head and heads to node. So these are the assignments over here. So we know that if condition and assignments take one time complexity. So this part of code also will take one time complexity. So these lines separately are one time complexity. So if you combine all together, it takes one time complexity. Now similarly, except over here also we are just checking that if the location is greater than the size. So we are doing some assignments over here. So in the assignment, we are setting the node's next value to null and tail next value to node and tail to this node. So this means that these 4 lines of code over here also one by one will take one time complexity. So all these if condition will take one time complexity. Now in the else condition, the things are changed. So here we have created a new node, which is temporal node, and assigned a head value to it. And this will take one time complexity. So then we have created a new variable, which is index variable, and assigned 0 to it. And this line of code also will take one time complexity. Now when it comes to this while loop, so this while loop will take n time complexity, because in the worst case, if you are inserting an element before the last element, so, and in this case, if the number of elements in the single linked list is n, so this loop will take n time complexity. So inside this loop, each time we are going to the next nodes and increasing index by 1. So these 2 lines of code will take one time complexity. Then after this loop, we are creating a new node and assigning temp nodes and next reference to it. And then temp's node's next reference to node and node's next reference to this next node over here. And these 3 lines of code over here will take one time complexity. Now at the end, we are increasing the size by 1. This means that this will take one time complexity. So if you combine all these complexities over here, O1s are non-dominant terms over here. So this means that it will take n time complexity. Now the space complexity is O1 because in this case, whenever we call this insertion method, we will insert only one node. So that's why it will take O1 space complexity. So with this, we have finished this lecture. So in this lecture, we have combined all 3 cases of insertion in single linked list and created a node which includes all these 3 cases. So hopefully everything is clear about insertion in single linked list. So see you in the next lecture.